Hello, this is Mr. Mitchell from Coosa High School. I want to talk in this video about formulas and units and how they apply to the high school physical science class. You may notice that I have here written out something called SI units. Yes, there are some standard units that are supposed to be used throughout the world from scientists and students who make measurements and put in physical science formulas. I happen to find online kind of a list of them. Mass is supposed to be in kilogram, length is supposed to be in meter, and so on and so on. Now, I have found in reality there are some formulas which can be converted to other things. For example, meters and seconds are often used as miles per hour or kilometers per hour for something like a train or a plane or a car or something like that. So the SI units are kind of in general throughout the world and not necessarily set in stone. However, for the physical science class, there will be units that you have to have for each formula. And in many cases, they will, in fact, be in these SI units. And you happen to see three of the formulas we're going to be working with in physical science. This one is for speed. Now, speed is also calculated the same way that velocity is calculated. So they have the same formula, distance over time. So I'll just go ahead and put that speed in this case is equal to roughly what the velocity would be equal to. But let's look at what distance would be in as far as units. Distance is the same as length. Distance is the length. So you will have meters that this unit will be in. So if you have the distance of 112 meters, then make sure that you do put the meters here. And that would be divided over the time. Time, as you probably guess, will be in seconds. So whenever you have the speed formula or the velocity formula, it's going to be in meters per second. So this is one where it could end up being asked for in kilometers per hour or miles per hour, but in many cases you'll have to convert from kilometers or miles per hour 2 meters per second, and that's something we'll have in another video. So make sure that for every time you do calculate these formulas that you do use the unit, and I think that's something sometimes people kind of forget a little bit. So let's take a look at this. This is the acceleration formula, and acceleration is change of velocity, and velocity, as you saw up here, is in meters per second over time, change of time. That's what these triangles mean here, change of time and change of velocity. And time is in seconds, as you saw back over here. Now that creates kind of an interesting looking unit. This is going to be called meters per second square. Now if you were to be asked what a meter is or what a second is, you could answer that. You could say a second is a unit of time that goes approximately from boom, boom. Meter is a unit of length that is a little bit longer than a yard. You can conceptualize meters and second. However, it's hard to conceptualize a square second. So what I generally tell people on these units is just know that meters per second square and all these units that are hard to get a grasp of, that are hard to conceptualize, treat them as just what the unit is supposed to be. So if you are calculating for acceleration, just understand, hey, your answer should be in meters per second square, even though it might be something you can't quite grasp. I can't grasp what a square second would be. That would be kind of funny if you looked around and saw a square second. So here we have another one. Force is going to be, I don't know if you can see this, I kind of cheated and put what these were already. Force is going to be in something called newtons, because mass is in kilograms. You may remember seeing this up here. Mass is in kilograms, and we saw that acceleration is going to be in this meters per second squared. So you can see the more complicated the formula, that it's not going to get any easier. I mean, if you have a hard time conceptualizing meters per second square, it's going to be really hard to conceptualize what a kilogram times meter per second square is. Just know that a Newton is what unit goes with force. And that's something that in each section of our class, you'll get to the speed formula, you'll get to the acceleration formula, and you'll get to the force formula, and you'll see lots of examples of where these are. But I don't want you to forget using the units. What I want to do now is give you some examples of formulas that we have, and whenever you get to the practice page, this is kind of what you'll have. So the math part, I think, is the easiest part of it. You just look in the problem to find what you're looking for. Here you have velocity equals distance over time. 12 seconds, is that the distance? No, it's not the distance, but is it the time? Yes, it is the time. So I will put 12 underneath the fraction symbol where it goes, and I've got to make sure to put the unit. 12 seconds. So what is left is 100 meters, which, as you can see, a meter is a length or distance. So you have 100, and don't forget to put the meters. So that way, whatever answer you come up with is going to be in meters per second. So I don't have a calculator on my screen right now, but I can go to my phone and quickly pull up a calculator. And there will be many instances just such as this where you can use a calculator to get what the answer is, but the calculator won't tell you what the units are. And that's part of what trips some people up, is that a lot of people can use a calculator well, and 100 divided by 12 happens to be 8.33. But what people forget about sometimes is the units. Meters per second is what you happen to have here. So if you were to punch this in the calculator, put 100 divided by a symbol and then 12, and that's what you ended up with, is 8.33 meters per second. So let's try another one. Oh, let's use this acceleration formula. Here we have Rosalind walked 2 meters per second, and if I would quit having to erase things, I'd feel a little bit better about it. But Rosalind walked 2 meters per second, but for the last 3 seconds of her walk, she sped up to reach a door before it closed. So she is accelerating. By the time she got to the door, she was walking at 5 meters per second. So the question is, what was her acceleration? Now, we have already seen the formula look like this: change of velocity over change over time. Sometimes you see this formula looking like this. This is literally final velocity minus initial velocity. But I think you probably have enough common sense to know that that's the difference or the change in velocity. So let's see what the change of velocity is. Let's see, velocity is in meters per second. Oh, I see meters per second here and meters per second there. So she was walking at 2 meters per second, and she ended up at 5 meters per second. So that is literally 5 minus 2 meters per second. 5 meters per second minus 2 meters per second. And you know, I could have just in my head gone, 5 minus 2 equals 3. But that's just the way I did it here. So let's see what the time is. Now this has to be the time in which she accelerated. So this last 3 seconds of her walk is what we're looking for there. So that would be 3 seconds. Don't forget that you are using the units here. So that equals 3 meters per second, because I subtracted 5 minus 2 over 3 seconds. Do you remember what unit acceleration should be in? It should be in meters per second squared. So 3 divided by 3 is 1. Wow, I picked an easy one on this one. 1 meters per second square is what that would be. So you can see what we have on the formulas. You are just filling in the math, and you're making sure to use the units. So you may have noticed that we have some practice up here. If you go to tinyurl.com/y3lv8tps, you can go to that practice, but there's a good chance that you might have been already given this worksheet whenever you got these videos. It's going to be the same worksheet, and this will give you access to it even if you don't know where it is after a while. hey, I hope this practice will help you on formulas and units. Thank you.